In this lesson, I'd like to explain why various languages are going to be used in this series of lessons. So the working file you're looking at is called languages.txt, and once again, it summarizes what I'm going to cover. So let me make a very important point at the beginning. This course really doesn't assume proficiency in any particular programming language, but it does assume the ability to program. Java and C are probably the favored languages in the course, and I'm going to explain why. The main reason for using different languages is that these different languages have different approaches when it comes to doing concurrency and parallelism. So let's start with C. So C is especially important, as I note here, because the operating system libraries that all of the languages use for concurrency and parallelism, those libraries are all written basically in C. In some cases with a little bit of assembly language, but if you're not familiar with C, C compiles into assembly language, which then compiles into executable machine code. So C and assembly are quite close. So when we deal with multiprocessing, for example, I've got a little list of the sort of C library functions that we're going to be looking at. For multi-threading, here's another very short list of the sort of functions that we're going to be using. And for non-blocking I/O, I've listed a few more down here as well. So C provides the underlying infrastructure for doing, in effect, concurrency, parallelism, and non-blocking I/O. It's as close to the metal as we're going to go. Let me reassure you that except near the end, we're not going to be looking at any assembly language. But when we do straight parallelism, even assembly language will have its benefits. Now, let me talk a bit about Java and C#, which are very closely related languages. In Java and C#, the preferred way to do concurrent programming is by using multi-threading. Can you do multiprocessing in Java and C#? Absolutely. Have the non-blocking I/O libraries gotten better in Java and C#? Absolutely. No question about that. But the preferred mechanism for concurrency remains multi-threading. So when we look at the Java examples, most of those examples are going to be multi-threading examples, and a few will be non-blocking I/O examples. If you consider the dynamic languages, which have also become quite popular recently, JavaScript, I'm really thinking now here of Node.js, in other words, a full-blown JavaScript that has access to the file system and all of that good stuff. Perl, Python, Ruby, all of these really favor multiprocessing as the way to do concurrent programming, and we'll get into some of the reasons a bit later. Finally, Node.js is particularly important because it has reinvigorated interest in non-blocking I/O. It certainly didn't invent it, but it really got the attention of a lot of folks, including myself. Now, from time to time, we'll see examples in other languages as well, so I'm going to move back up just a little bit to this line. I'm going to look at examples in Go. I'll talk a little bit about Clojure, but not do any examples in Clojure. The reason Go is important is that it has emphasized new approaches. Well, technically not really new. As you know, in our business, everything is basically been done before, or at least it seems that way. So Go has revived interest in an approach taken in the early 1970s for doing concurrency. We're going to be looking in particular at Go routines and channels. It's very useful. Other languages, Java for example, has now started to copy some of the approaches that have been taken in Go. So I realize that it's going to be a bit challenging to move from one language to the other. Let me assure you, before we actually get to the code examples, that I'll explain each of them very carefully. Our interest is not going to be in the syntax, how do you do this in C, how do you do that in Java, that sort of thing. Our interest is really going to stay focused on concurrency, parallelism, and non-blocking I/O. The examples will really be helpful. They'll get us close to the metal, but we won't get distracted by syntax details.